Hey there, and welcome to the Future Ready podcast from Siemens. My name is Connor Pike, and I am a marketing writer at Siemens, as well as one of a few hosts that you will find on the Future Ready podcast feed. In this episode, we have the conclusion of my conversation with Dominik Zettler, Vice President of Simulation for Industrial Systems at Siemens, and one of our resident digital twin experts here on the Future Ready podcast. As we continue, Dominik and I discuss how companies are approaching the structuring and management of data in support of industrial AI, data orchestration from many existing systems, how the digital twin can be deployed in real time on production lines, and then we close with some thoughts on the Industrial Metaverse and a brief summary for the listeners. So thanks once again for joining us here on the Future Ready podcast, and we hope that you enjoy this discussion. And one thing that you're talking about training the AI models, and I think that brings up one of the key aspects of AI, at least so far, is that it really demands a pretty huge amount of data. And of course, companies have lots of data. They don't maybe always have it structured and prepared in a way to help train an AI or to apply it, right? But do you think the digital twin, maybe in a production sense, does that support that? Is that a benefit in that aspect as well of organizing the data from the machines perhaps and getting it in a format such that it becomes easier to use it to train AI or to continue using the digital twin in operations as well? Does that make sense?
No, absolutely. Maybe we should have here a look into, I don't know if this is the precise wording, but I would say we have a digital twin of data as a data digital twin, but I would say it's only the data part itself. If we have now a digital twin and data, then we have also synthetic data, and we can also look what the perfect data should look like and what is the real data. So I have different topics also to look on the quality of data and if how they behave, the data. But data in general, for sure, is here and there the biggest topic of industry, because you have different data lakes, data oceans, and so on. And this is really for sure, if you bring it to operations, you need to overcome the data management itself. But if you start quite early and think in a digital way with digital twins upfront already, then you can implement it also much easier in the future, and then you can always compare and bring it into a correlation. Yeah, and this is basically the bigger topic, that we bring then the right things together and say, okay, this is relevant, this is not relevant. We can't take care about all data. We need always to think what is the use case, where I want to use it and where not. But this whole topic of data is a big animal. We can spend, I think, 1 or 2 hours only talk about data in the production.
So one of the next topics, and maybe we can quickly talk, talking about data and the aggregation and the orchestration of data into, structured formats that are usable and such that you can apply things like AI to them. One thing that has come up recently is we had a recent announcement about the digital twin composer. I'm wondering if you could talk us through maybe like, what sort of problem is that helping to solve? It seems to me like it's helping with that data orchestration task.
No, absolutely. And it helps in the data administration task. And there's a second topic where AI helps, but also digital twin composer in the core itself, enabling more personas to access the digital twin capabilities and access the data. With the digital twin composer, we basically build an overlay about the data and also the virtual environment. So we call it a scene. That in digital twin composer, we bring in then data from the shop floor, in example, or from production, or maybe even from ERP systems, and can bring it together in a view with virtual data or simulated data, or we can visualize things based on a simulation model, and the simulation model is feed it by real data out of the shop floor, and we make things visible which are invisible in reality. In example, you can't see the temperature in an oven. Yeah, so you need a simulated model because you can't also not place a sensor inside the oven. Yeah, but you want to see, maybe I see some outside data from quality, maybe for the hardening process or whatever, but then I can make it visible because I have maybe a digital representation, a digital twin of this oven with a thermodynamical model, and then I can really visualize the heat of the oven combined with data dashboard, and then I have a total new view, and this view we call then scene. That means we put all these topics together, the digital twin capabilities and the visualization of digital twins combined with data out of different sources, and we can then also tailor it personas and use cases, what is the need of the customer. So a quality manager might have a different view than a maintenance guy, than a planner, than a shift operator, than somebody else. Yeah, and some of those personas, they are interested in the quality of the process, and if it has an influence, some are interested in how I can schedule the next production shift or whatever, how I make my material flow or whatever. Different personas, different industry, different views. With Digital Twin Composer, we have a tool set that exactly we can utilize those data and bring it together with digital twin information and make, even in the best cases, things visible which are invisible in the today's world. So we talked about a digital twin, comprehensive digital twin composer. The digital twin composer is basically also helping me to put data, different sources of simulation tools together in a scene. And then we have now executable digital twin. So we need also, I think, shortly explain what means executable digital twin, why we call it executable digital twin. So executable digital twin is if I run it in real time in the process. So it's executed 24/7 or when production is running. Yeah, for digital twin of a component, I'm utilizing it here and there, and I feed in data. But the XDT, it's embedded into the production itself. You mentioned virtual sensing. This is one of the also good use cases to explain. Take the example of the oven. I can't measure the temperature in the middle. Maybe I put two sensors on the side of the oven. Then I can calculate or simulate the temperature in the center. Virtual sensing. But this sensor, it's not only that I can visualize it maybe on my dashboard or in my scene in the Digital Twin Composer. No, I can use it as a real value in my real plant. So my PLC can really take this value, and based on this calculated executed digital twin, I'm operating in real time. It's not that a guy or somebody else need to adjust something and say, oh, I see it now and I need to manual do it. No, the executable digital twin of a dedicated topic, physical behavior, or whatever it is embedded into the process and acts in the process. You don't need a human to do something, whatever. It's executed in the process.
And what I think is so cool about the executable digital twin is the way that it is, and it can run real time on the edge, right, on the device that it is modeling.
Yeah, for the XDT, I want to add one or two things here, and because we need to have a virtual sensor, it's not so super rocket science, yeah. But
right.
But you need to think about further topics and so on. First of all, we run it in a Docker container, and we run it basically executable online, so we can also remodel it and deploy it new. That means if we have a new material or whatever, yeah, it's no problem. We can simply have 2, 3, 4, 5 models, and according to maybe changing environmental informations or material informations, we can deploy it new and adopt it seamlessly. Yeah, and then we could also think about various use cases. This oven topic is thermodynamical, but we can here also simulate chemicals, fluids, gas, mechanics. So we can also go for predictive topics. So we can run a digital twin in parallel to the real production, what you mentioned with the data, and then we can also see if it should behave and it is behaving and so on. We see deviations much earlier. We have also this famous use case, this spray drying and so on, when we have processes which are highly energy expensive, where we have a liquid spray drying. To shortly explain it to the audience, that means take milk powder. You have milk, you need to heat it up, that in the end the liquid is gone and that you have powder. Very simple, yeah, more or less. But you normally put a lot of more energy into this process to ensure that you have powder in the end. But if you know, I don't know, maybe the fat in the milk and some other things and so on, you can also seamlessly adopt this process that you have the right quality. So you're increasing the quality. You can also reduce your energy in these topics, and this you can implement in various industries and topics. Doesn't matter if it is leakage for, I don't know, piping here and there or other things. Also here we can talk about various use cases in various industries where we could apply such topics.
Oh, that's awesome. And I mean, it's so cool to think about if you had maybe a input, your milk comes in and it has a slightly different fat content. In theory, you could adapt to that on the fly to make sure that your process doesn't end up costing you a lot more energy or your quality suffers, something like that. So
exactly.
Yeah, that's real. I mean, that's such a, like you said, it maybe seems simple, but to me, that's such a cool, a cool use case for this real time, digital twin that's running right there. So that's, that's really amazing. But what I think, if we take some of these technologies we've been talking about, we start thinking about how they can combine, and look a little further into the future, we have this. The evolution of the digital twin into a technology you've already mentioned earlier in the recording. So it seems to me that what we're doing is building a foundation for something that's quite a bit bigger, and it's this idea of the industrial metaverse, right? So what does the future of the industrial metaverse look like to you? And what types of things can companies someday be able to do with such a technology?
I'm dealing with this topic also a few years now, and there was also on the CES, Roland Busch was just make it prominent, I would say, 2 years back in 2024. And since then, we had also a lot of customer engagements in this field of industrial metaverse. So what we also need to explain, and where I was in several discussions, it will be not the one and only industrial metaverse. It will be, let's call it private industrial metaverse. Maybe one large enterprise will have their industrial metaverse, maybe other large company will have their. Why? Because they are taking care about their data, their intellectual property, they want to control their suppliers. So for sure, they bring their suppliers the idea of bringing all those disciplines together, exactly where we started with this digital twin, comprehensive digital twin composer, maybe executable digital twin. These are all ingredients and building blocks to make the industrial metaverse in the end ready, because we starting maybe in the design phase or in the ideation, go through the whole time, but also the life cycle of the production, virtual worlds, bringing the suppliers in, the suppliers of the products and components, but also the suppliers of the machines and lines producing it and so on. And then if we take this whole big thing and all these disciplines together, then we have metaverse. But what I see and on the market is we will have private industrial metaverse owned by companies and operated by companies because of intellectual property, technology, what I mentioned before, a topic, export declaration and control and things. They need to control it. And maybe I'm wrong. Also maybe somebody could convince me from something different, but I could not imagine that there will be one and only industrial metaverse for everybody, because who need to control it? Like in an industrial metaverse, what we know from the consumer industrial metaverse, from Second Life maybe, you need to have also rules, can I destroy from somebody's object? Yeah. How do I do money transfer and so on? It will be super complex. We need then talk about Web 3.0 topics, non-functional tokens, and all those stuff. And I don't believe, as at least not the next 10 years. Yeah. Then let's have a look again that we will have the one and only thing where we could be in a B2B environment. So I see at least the next 10 years. Yeah. Growing private industrial metaverse from in the beginning large enterprises, and then let's have a look how good we can democratize it, make it easier access. We talked a lot already about easy and so on, and we can do, and we have also a lot of things in the pipeline for the next years and ideas to make it accessible. So we will see that will be spreaded into the market step by step, but it will take also what I mentioned, years. Now, if I took my journey, it was 25 years up to now. I will have maybe 20 years to go, at least in a job. So let's have a look where we are in 10 years and where we are when I will go to retirement.
Yeah, absolutely. Yeah. For now, let's focus on maybe the 10 years time horizon, right? How do you see this concept maybe evolving some of the capabilities we already have through the digital twin composer, industrial AI, these things that are already developing and applicable today? Where do you think the industrial metaverse concept can combine these capabilities and deliver additional value to companies as they, continue on their path of digital transformation?
As one aspect is for sure where we see already today topics we mentioned in the AI perspective and also with the digital twin composer, that we enable more personas to interact with complex use cases and make it accessible. And here is also a way to go to make it easy and smooth. We can already, and this we have demonstrated 2 years back already, a one-off we can do already today. But it is easy to handle, and all the building blocks are smooth, and all the use cases are clear. I mentioned also before, we need to better translate it to different industries and so on. Yeah, we normally as Siemens start with an agnostic approach and have a look. For sure, we prove it with different industries. But this is also a way to go the next years to make it smooth, more integrated, and do not have one-off. We could do it since years already, because with a lot of labor, you can assembly and program a lot of things, but it needs to be easy and smooth. And that's why we also go already since years the way of the digital enterprise, digital twin, comprehensive digital twin. It's not a one-off topic for us. It's also for us an evolution, what we are running since years. And the journey is not yet the end, also not for us. Also, I see a lot of capabilities or topics which we could do in the future, where we could even better support our customers, make it easier, make it more digestible, whatever it is.
So as we come to the end, Dominik, I'm wondering if you could have our listeners remember maybe just one thing about comprehensive digital twin, the future of the digital enterprise, the digital twin composer, any of these topics that we've covered today. What do you think you'd like the listener to take away from today's conversation? I
would say it's important to not be afraid of it. So there are different words. The word sounds super fuzzy sometimes. Digital twin composer, you mentioned it, executable digital twin. You can get lost in translation only with these terms. So what listeners should really keep, it is doable. We do it since years because the easy entry use cases are really doable. So take a first step into the world. I can repeat what I said, I think twice already. Think big, start small, and this is what all the audience, the listeners and so on should keep in their mind. It's doable. It's not rocket science. It's you need to select the right thing and then go for your digital twin metaverse journey, whatever you are aiming for and you could dream about.
We love to get excited and talk about all the things that are developing, the new technologies coming up. But if it bears stating, I suppose it bears repeating. And think big, start small.
Absolutely, and I'm we discovered also we have a lot of things where we can go even deeper or left and right into the topics. I think we had today in this whole podcast now a good overview about digital twins, digital twin composer, digital comprehensive digital twin, executable digital twin, and all those things. So we have brought all the things together, and we can go here and there also left and right a little bit more into the topic itself and the use case and what is really, this is for me always important, the value. As this we didn't talk today. I mentioned that we should go for low-hanging fruits and so on, but we could then really also go for the value. I mentioned it with the spray dryer, an example, lower energy, higher quality, but we can then also take some use cases, what it really brings, because it's really money behind. If you go for this journey, it's really being a thought leader, increasing quality, lower energy, reduce cost, and all those things. And I think here we can also give the listeners in the future more insights, what is really possible on a specific use case or if we apply it correctly. We also, dear listeners, if you have topics you want to hear or better understand, then make please a post or whatever that we can have a look and that we can look that we tackle those topics then maybe in a future version of our podcast.
Thanks again for joining us on the Future Ready podcast. You can stay tuned to the feed for future episodes featuring Dominik in conversation with other experts from Siemens and beyond, exploring the future of the comprehensive digital twin, the industrial metaverse, and other key technologies. And if you enjoyed today's conversation, I encourage you to subscribe to the feed to hear from experts from various backgrounds, diving into the most important trends and technologies in industry today. So thanks once again for joining us, and we hope that you will come back soon.